that you see the shadow on the fog, in this case, in your case, on the steam, and then the glory around you, which is a logical consequence of the size of the water drops. That's very rare, and I've seen it because I've tried my whole life, and I've taken some pictures of myself. One of them is in the book. That's rare.
Yeah, it was a surprise.
It's very rare, yeah.
Another one I saw was, just the standard one. I was looking at the little airplane on the ground and seeing the halo around it, and then all of a sudden there was. It grew enormously. I almost jumped out because there was a cloud bank. So I'm looking at this little tiny thing, and then we flew by a cloud bank, and it became gigantic. It was like
that's
the top me.
No, it's the size of the raindrops. It's not how close you are to the cloud. It's nothing to do with your distance to the cloud.
Really, because it had or maybe it was just because, maybe it wasn't any bigger, but because it was projected on something closer.
The size of the smaller the smaller the drops are in the cloud, the larger the glory is. It's deflection, so it's obvious.
Obviously, I'm not a good observer, so maybe but I definitely had a sensation of it, coming at me, but then realizing that it was being projected on something closer. But really, it was the same size.
Well, no, the glory changes in size because you can fly over clouds with the different sizes of the drops. And then you will continuously see the glory.
So it could have been larger, but not because it was closer.
10 times, no.
Not because it was closer, but
in general, they are 3, 4, 5 degrees, but they can go up to 10, yeah. And you see a repetition of the colors. Not like a rainbow that you have red outside or blue inside. Not like that at all. Yeah, glories are very common. If you fly, I always book a plane. In a plane, I always book during the day a seat away from the sun. Always. To see glories, and I photograph them, yeah. And it's not uncommon that you see them. And of course, if the airplane flies very high, then you don't even see the shadow of the airplane, but you still see the glory. But if you fly lower, then you actually see the shadow of the airplane. Depends on how low. If you're very close to the cloud, your shadow can be almost as large as the size of the airplane, right? Because the rays from the sun are infinitely far away. So if you're very close to the cloud, then your shadow is the same size as the object. So I've seen huge clouds, but in general they fly at 30,000 feet airplanes. And the clouds are very low, so it's very rare that you see a big airplane. But I've taken pictures of sizable airplanes, sizable. And you can also later see where you were sitting in the plane. Because you were always exactly at the center of the glory. So if you see the plane, and you go to the center of the glory, that's your seat in the plane. Yeah. And so you will never sit above the wings.
Right, because
then you can't see it.
Well, you get the pilot to hang.
Well, yeah, that's a good point. So that's why I always ask the seat just behind the wings, to be sure that we can play the view.
By the way, we're going to actually have an official start. We should start at 1:05. We have another group of people coming in. So let's start about 5:05. We'll bring over here. Oh, you want to just do informal?
Yes.
Okay. Some of the folks here are feeling a little like, oh, I want to ask a question. Or do you want to do it like this?
Anytime. I mean, that's the idea.
Oh, okay. You want to just do it like
completely
this?
informal, yeah. We are eating and having a conversation.
Did people, do you have questions? I mean, you're kind of looking outside the inner circle.
Just like speaking so loud.
Maybe it's been up to.
Excuse me, was that a question?
Yeah, it's like asking what you've been up to. Like, you used to teach. You retired. What have you been up to?
I don't teach courses at MIT anymore, but I do give a lot of lectures, largely outside the United States. The reason for that is that I've written a book which came out a year ago The title is For the Love of Physics. And that book has been translated in 10 different languages. And it's been translated. So whenever one country is finished, they want publicity. And then they want me to come, give a lecture, TV, radio, the whole thing, newspapers, everything. I had that in Barcelona just a few weeks ago, and I have it a few weeks from now in the Netherlands, and I will have it in Russia. And that will continue for at least a few years. And then they always like me to give talks. And also, I still give talks in the United States at universities, no classes. And frankly speaking, most invitations for talks I turned down.
What was the turning point for you when you went physics? This is what a subject I really love. Was there a turning point for you whether you're in grade school, high school, college?
No turning point.
No turning point. You're always a physicist.
No, I know that you all feel disappointed because particularly news people who interview you, they want this mea culpa thing, you know. One day I went to bed and the next morning I knew I was going to do physics. It's not.
Were your parents physicists?
Very slow process.
Slow process. And where did you grow up?
In the Netherlands.
Okay.
Very slow process. It was actually a negative choice.
You mean you ruled out everything else?
Yeah. No, it's true. In that case, it was a negative choice. I didn't know yet that I was made for physics and that physics was made for me. I didn't know that. But that came later. It was really
English literature.
It was absolutely a negative choice. I ruled out everything else.
So at what point did you like narrow down your choices to physics? I guess like art, university?
No, you never narrow down things. If you want to be successful in physics, you have to move around through fields. I was in nuclear physics. I got my degree in nuclear physics. But when I came to MIT, I changed to astrophysics, to X-ray astronomy. Narrowing down is claustrophobic for me.
I think that was.
I don't narrow down.
It was over there.
I know, but you're talking about like a negative choice, right? So it's like the process of doing that. When did you narrow? When did you like come to the negative choice of physics?
When you are what saying?
When did you come to the negative choice of physics?
Oh, that was. Let's see. I came to university in '54. Yeah, that was around 54. So let's see how old was I then. That's difficult to calculate that. But I was 16, 17, 18. Yeah, then I knew I wanted to do physics. But it was not wholeheartedly yet. It was a negative choice. Seriously. So I grew into it. So how many of you, when you came here, most of you were in the first year. Who is in first year? All right. So my statement was reasonably accurate. Who knows now definitely what they want to major in? Raise your hand.
Oh, no, come on. That's not raising your hand. Look at that.
Okay, that's nice. Half of you don't. But that's already nice if you really know that. That's very nice. When you came to MIT, before you took your first year, who knew then already what you wanted to do? It's the selection effect. That's why you came to MIT. So I get so many emails every day from high school students, dozens. They all ask me advice on what they should do after high school. I cannot give them any advice. But it shows that they clearly have no idea, absolutely no idea. Because I ask them questions, we email back and forth, and they have no idea. That's more common than knowing. But I think MIT is an exception because of the selection effect. You know, it's a very special school. And so anyone who ever in his life wants to do EE is computer science would be stupid to go anywhere else than MIT, right? So that's the selection, I think. Of course, 6 was always the largest department at MIT, always.
Even before computer science was
The what?
even when it was just electrical engineering?
When it was what?
Just electrical engineering. It was still the biggest?
Oh yeah, when it was course 6, EE. Oh yeah.
Yeah.
Oh yeah, well, that's because when I came here 45 years ago, TS didn't exist yet.
Yeah.
No one even knew what a C was, let alone. So yeah, it was the largest.
Yeah.
How did Nicky?
And F801 and 802 were institute requirements. So the majority of the students that I had in 26-100s were EE people, not physicists. In fact, most physicists took 8011, 8011 and 8021. Yeah. So EE was my bread and butter.
So for a long time before coming here, I saw some of your lectures and you have dotted lines. And for a long
What before you came here,
yes.
you watched my lectures.
Yes.
You better. I would have felt insulted if you hadn't.
And so for a long time, I thought when you made those dotted lines to chalk, it was special chalk or something. But then after coming here, found out how to do it. But how did you learn how to do that in the first place?
Well, it is not special chalk.
Right. I figured out how to do it, but I was wondering how you learned.
Can you enlighten us all?
Oh, my math teacher did that on the blackboard in high school. And it is trivial about 2 or 3 weeks ago, the physics department had something, I don't know what it is, but physicists are all part of that. And then once a year they can invite one professor to have dinner with them. And then there's a lottery who can come and who cannot come. And they end up with 10 people. So I had dinner with 10 people as legal people. And so this issue came up. The dotted line comes up every day in my email. And you can't explain it. Because if you explain it and they try it, they still miss the point. But come to my office, it's 5 minutes at most. And so all mine one day
They shut up.
came, and within 5 minutes they all knew how to do it. So once I was standing next to me and I hold your hand, and how you have to hold the chalk, and in general they hold the chalk too tight, they draw a line instead of a dotted line, you have to hold it a little loose. But to explain how you do it, not an unwillingness on my part, it's impossible. But if you're really interested, I can't answer all of you now, but if you're interested,
Could you show us?
just come with me and I will show you in 5 minutes how you do it. That you tried it yourself and you found out how to do it.
I did, yes.
You cannot do it with a short piece of chalk.
Right. Yes.
It has to be about this long. But you can do it with the thin chalk, you can do it with the thick chalk.
Mm-hmm.
The only difference is you do it with the thick chalk. The thick chalk, you get a thick line with the thin chalk. That's physics, right? But of course, when you get a very experienced physicist, then you can make the distance between the dots anything you want. You can make them a millimeter apart, you can make them an inch apart, but that's only a matter of practicing. Once you get the idea, you can teach yourself all that. In the beginning you can only do it vertically, then after a while you teach yourself how you do it horizontally. Now the hardest is to make a circle. Because the reason is you have to change the position of your pulse. Because if this were a piece of chalk, and if I do a vertical one, and the chalk is always pointing down. So this is the way the easiest to learn. And this is not so difficult either. But now look, you have to go horizontally, you now have to make a circle. So far so good. So far, so good. But now you're in trouble. And now, it's even more. So a circle is the hardest. That can be done. And you've seen me do it. There's a videotape that someone made on YouTube which takes out of all my 801 dotted lines. Have you ever seen that one?
Walter Lewin and line.
And someone later added music to it. It was even worse.
I've got another question. What discovery in physics that most scared you? What
Scared me?
Yeah, nothing scared you, but what? Is there anything that you think, wow, this is kind of unusual, scary,
Discovery is
thought-provoking,
scared me.
Completely.
I can't think of anyone that scares me.
dark energy?
What?
Dark energy?
That doesn't scare me at all. I don't know what it is. So why should I be scared about it?
What recent discoveries
I
excite
can only be scared about something if I fear that it can do harm to me. That would scare me.
So where?
The dark matter, we don't know what it is. We don't know what dark energy is, so nothing to be scared about. That's been there for probably 4.5 billion years. Has not done anything bad. The fact that it accelerates the expansion of the universe, big deal. You know, that's a billion light years away from me. Far from home, so to speak. No, I don't think I can think of anything. No, if anything that scares me in science is the potential that biology has. It has a potential. Because, well, yeah, in biology they can manipulate genes. They can create human beings, in principle, that have certain characteristics. That's scary. That's really scary.
They're running for the Republican primary.
They're coming what?
They're running now for the Republican primary.
What most excites you recently? What discoveries most excite you?
What?
What discoveries most excite you recently?
Oh, there's so many. I think Newton's discovery that you can, in a very simple way, all of a sudden understand the entire motion of the planets, which before that was hocus pocus and nonsense. And then Kepler came, and he came with 3 laws, but no one had any clue why these 3 laws. And here comes one man with one equation, and he explains the whole thing. Mind-boggling. Absolutely mind-boggling. Yeah, that's, for me, that's number 1, and then Einstein is probably number 2.
And recent discoveries?
The what?
Recent discoveries. How about like in the last 50 years?
Discovery of DNA. The DNA is a double helix. Probably the most important discovery ever made in the history of mankind, except for Darwin's theory on the evolution through natural selection. That's even more important. Now, those are milestones. Unbelievable. But the double helix, think about what that is. That's the scary part. Now they can manipulate the genes.
What were your thoughts on the experiment at CERN before I found out that they had made a mistake? Did you think that they had made a mistake, or did you think Okay.
I gave the odds that it was wrong 1 in 100,000. That it was right 1 in 100,000. And my reasoning is the following, although it's not ironclad. Well, okay, I have two reasons. One reason is that you realize you cannot prove that the speed of light is the maximum possible. Einstein cannot prove that. He postulated it. Right? Well, if you postulate something, it can be wrong. But with that postulate, he developed special relativity. Special relativity has been tested now for almost for hundreds of years. And the most absurd predictions of special relativity all turned out to be correct. So that was the main reason why I said it has to be wrong. There was another reason, that is, we do know the speed of the neutrinos from the supernova 1987A. The supernova 1987A was on January, I think it was 27 in 1987, that the supernova went off in the Large Magellanic Clouds. It's 170,000 years away from us. The third claim was that the particle went faster than the speed of light by 1 part in 100,000. Yeah? If that also were true for the neutrinos from the supernova, then the neutrinos would have arrived 2 years before the light arrived. We know that that's not the case. Now, when exactly the explosion took place, we know no better than about 3 days. If we take that into account, we know that the speed of light, that the speed of the neutrinos was consistent with the speed of light to 1 part in 10 to the 7th. On the other hand, those neutrinos from supernova 1987A had an energy of 10 to the 16 electron volts, and the ones from CERN was something like only 80 or 30, something like 80 GeV. So they were not identical. They were a little bit apples and oranges. But I accepted bets 1 in 100,000. Did you have any doubts?
I didn't really know what to think. I wasn't well versed enough in physics. Whatever.
Einstein's theory of special relativity had been wrong. You know, the GPS wouldn't even work. You need both GR, general relativity, and special relativity for GPR and for cell phones to work. Because GPRs, you have to be corrected even for the gravitational infall of photons. Have to be corrected for time dilation, even though it is minute. Well, but if you're off by half a mile, then you're too far off. So the precision, the bombing precision nowadays is absolutely incredible. That's only because of general relativity and special relativity.
Professor Lewin, when students tell you they don't like physics, what do you say?
Let me say this again.
When students tell you that they don't like physics, what do you tell them?
I don't have to tell them anything. I know they're a lousy teacher. That's all there's to it. For only one reason. Seriously. No other reason. I can make anyone love physics, even a dog I can make. Not joking.
He was testing mechanics with my dog. You were teaching mechanics to Balu, to my dog.
Well,
He knew some.
he was an early target, yeah. He was very intelligent because he was with you, of course. So he was an easy student. Yeah.
Would you like something else to eat? A little bit more soup.
No.
No?
I told you that.
Okay.
after Barcelona, I was weighing 15 more pounds than I wanted to.
I'm from
Yeah,
Barcelona.
my mom went to see your talk actually, and Museum of
want to
Science. My mom went to see your talk in Barcelona. I'm from Barcelona.
She came to my talk in Barcelona?
Yep.
Oh. Yeah, they really treated me very nicely.
Yeah, I don't know. I like the city. It's where I was born. What am I going to say?
Nice city too. It's very noisy. Like
Yeah, you guys are really silent. I like go in the subway and everybody's like silent. This is not normal.
the noise is unbearable. It's even worse than in New York City because New York City is largely cars. Barcelona is largely motorcycles. And that has to do with the number of people, space available, and of course it has to do with economy.
Yeah.
So the number of scooters is unimaginable. Really, you can't even count it. And they make an enormous amount of noise, and there are no restrictions by law on the sound that they can make. So you at a red traffic light, and there they are. And you don't even what to do. What I do is I take my hearing aids out. Because once they go on the red light, it's also part of the Spanish fashion. They pump the gas and they go, and the noise is truly unbearable. Have you been in Barcelona?
What? She's from Barcelona.
Yeah, so you know.
Yeah.
So you know I'm not exaggerating.
I mean, no, like, I don't know. Spanish people are definitely way more noisy than the people around here. Like, everybody tells me I'm really noisy, and I'm like, well, you haven't met my family. So, yeah. I don't know. We're used to it, I guess.
Yeah. France, we pay for modernization. But the architecture in the Garuda buildings are just so incredible.
Yeah.
So fantastic.
Yeah. Did you go to the Sagrada Familia, the cathedral that's like, I don't know how that holds. Actually, I don't know how that physically can hold.
I know exactly which building you mean. I'm allergic for crowds.
Oh, okay.
And that building,
Yeah, that's a problem.
people were lined up roughly a mile.
Yes.
There were other buildings like Gaudi, which you could get in about 15 or 20 minutes, which I did do. Not the big one on the hill. You know that this building is not finished yet.
No, it's not. And
It's been under construction for more than 100 years, and is not finished yet.
yes.
That alone is interesting, isn't it?
Yeah. It's raised by, well, it used to be raised by donations by people, so the construction would vary depending on how much people would donate. So now there's tourists, so we're okay.
Yeah, it's the most famous building maybe of all of Spain.
Majority of people would get mad at that.
Maybe Gehring's Museum.
Oh, right.
The Garuda building is way more famous than Gehring building. People come from all over the world to see that building. But he has built, Gaudi has built many buildings in that city. And there's all of the time in those houses. Unimaginable. This guy was literally 100 years ahead of his time. And there's not even any architect that came after him that you say, hey, yeah, that's Gaudi. He was really a singularity in the field. He wasn't copied later on. You can find anyone later. No one that you say, comes a little close. Don't even come close at all. It was really a singularity, and 100 years ahead of his time.
It's pretty great, yeah.
And that same country produced Picasso, who was also a singularity. So So you did do well.
We have a lot of artists. We're like good at drama, so we know how to do art. That's my opinion.
Well, you have Miro, didn't do so poorly. You have Dali. I hate him, but no, he was Spanish. He's world famous.
Yeah. Dali was a serious person too.
Yeah, it's not a small matter. It's a relatively small country. Now, I'm Dutch, okay? So we have Rembrandt, we have Vermeer, we have Van Gogh, we have Mondrian, and we have Willem de Koning. I think we can beat Spain just barely.
I'm not.
Because
good
you have
fight.
40 million people, but we only have 10 million people. And we take that into account.
Yep, that's true. I know, we also like spend lots of time sleeping, so.
We have Leonardo, Michelangelo.
Give you credit for that. You deserve it, absolutely. It's very strange how concentrated in a few countries and a few centuries, because largely what you were referring to is the Renaissance, and then the 17th century was the Dutch.
Professor Lewin, do you have a favorite topic in physics?
No.
Do you have a least favorite topic in physics?
Thermodynamics.
Why don't you like thermodynamics?
Don't even ask me.
So you didn't just have a lousy teacher?
Probably. No, what you're saying is probably true. When I think about it, I hated it already at university, probably because it wasn't taught properly. I remember that for me it was manipulating math without knowing what I was doing. That's the worst thing that can happen in physics. It's not uncommon. Yeah, so I always... So they asked me to teach StatMech at MIT. I said thanks, but no thanks. No.
What was the biggest challenge in your career? Was it like within your research, or within teaching, or was it like working with administration?
Well, I get that question very often. In my early days here, I was so lucky to come here at the right time when X-ray astronomy was just beginning to lay one golden egg after the other. I mean, we were just lucky. I joined it within 3 years of the discovery, and I started flying balloons at very high altitude, 150,000 feet from Australia. And so I made some very lucky discoveries early on. So that was really I would say my first 10 years at MIT were focused largely on my research. And then slowly when I started lecturing, my first lecture, I always did recitations, of course. You have to do recitations when you're faculty. But my first lecture started in 72, 803. And even though I already taught physics when I was 25 years old in the Netherlands, I began to like it more and more. And I now like to think, now that 104 of my lectures are on the web, which are being seen by 2 million people every year, that may actually be my legacy, these lectures, rather than maybe in fact, the research that you do when you're young, even though it was important, is so quickly forgotten. So you make some important discoveries during 10 years, You think 40 years later people remember that? No, maybe only a few major discoveries, though mine were not in that category. People remember that Hubble discovered the expansion of the universe. That may be all you remember from the 1920s. I can assure you there were many others. If I asked you who discovered Cepheids, you have no idea. It was a very important discovery. And so, that's forgotten. My lectures won't be forgotten very fast. It will take a while. No, the fact that most of you have probably seen it speaks for itself. And for those of you who haven't, please leave the room right now. Yeah, so I get a lot of email every day that I have to answer from people all over the world who ask me questions. I answer everyone. It takes me two hours every day to answer them. When I go back now after this luncheon, there will at least be another 10. I only answer if it takes me less than 5 minutes to answer. Otherwise, I'll be the whole day there. But it's very common that they ask me to do their homework. That's very elegant. They give the problem, they send you an attachment, and they say, you know, we have an exam tomorrow. We have to know the outcome. We have to know the problem. And then my standard answer is, are you taking the exam or am I taking it? And that you never hear from them. Seriously, they insist on the answer within the next few hours.
A lot of teaching in like classrooms have like gone online, like with Khan Academy and like OCW and stuff. What do you think about like that modern age of learning online rather than learning in the classroom?
It's a revolution. It is a revolution which is as important as the invention of the printing press. Because imagine, when the printing press was invented, more than one person could read a book.
Right.
Before that, people had to work on copying. It might take 10 years to copy a book, and then a second person could read. Right? And now all of a sudden you can print 100. You can print 1,000. That was an unimaginable revolution, which we are not aware of anymore. Believe me, it was. Then the second most important was probably radio, when radio was invented. That all of a sudden the world, which had a diameter of 6,000, a radius of 6,000 kilometers, all of a sudden became 1 millisecond in size. That was the second revolution. This of equal magnitude. Now, you can reach 7 billion people if all they need is internet and a laptop. You've only seen the beginning. It's incredible revolution. Take that thing away from you which you have in your hand. That tells you how important it is.
Yeah, definitely.
You can't even live without it. You're addicted to it. You might as well admit it. Text messages from your girlfriend right now.
Professor, do you think that the standard lecture, like with people actually sitting in the classroom, is going to go away and it's going to be completely replaced by videos?
I think it will be reduced. Whether it will completely go away is hard to tell. For one thing, in biology, I don't think it will. Because there, you have to learn, put the knife in, get the blood out, and I assume you have to be there.
Maybe that's great virtual labs.
But in math, it may quicker disappear than in physics. Certainly, there will be a dramatic A dramatic reduction, yes.
That is that.
And there can be. In other words, there is no need why there should not be. Because once you have lectures videotaped and they are of high quality, why would you punish another 30,000 physics professors in the world to have to prepare the same stuff? Why would you? What a waste of energy and time. And they're probably not as good. You get the picture, right?
What's the value of this?
There are many universities in India. I get so much email where I get professors show my lectures, then the students have to see my lecture at home. That's the first requirement. And the next day they see it together in the classroom, mandatory, and then the next day, no lecture, they discuss it. That's ideal. What more do you want? The teacher has all the time then to prepare himself for possible questions. They see wonderful demonstrations, it gets them enthusiastic, they like it, they love it. It's the way to go. So, yeah, that means less classroom time has to go down. Now, whether it will ever go down to zero, I think it will depend on the subject.
Do you think that people will attend universities across the world just by computer though?
People what?
People may attend universities across the world just via computer. Like a university will become a virtual thing and it won't actually exist in a physical place.
It depends on the subject.
Yeah. But math, you think that?
I really believe that math is probably one of the first that could completely disappear from the classroom. It may show my ignorance, not knowing exactly what is involved in math, but you have no laboratories, and so why not doing it on e-learning then rather than in the classroom? Yeah, I think, and there are others. I would have to think about it, but yeah, many will disappear. Whether all will disappear and to what level, I do not know. But yeah, 50 years from now, it will look, universities will look very different. But of course, institutes like Harvard and MIT will still do research. So there will be a shift then away from lecturing, away from education to research. But there has to, these are centers of excellence. If they stop doing research, that's bad.
Yeah.
That's very, very bad. That's where the Nobel Prizes come from, you know, just from a very small number of schools who are centers of excellence.
That is right.
And originally the universities were doing that. Are still doing that, sorry. You want to ask a question?
No, I don't.
Professor Lin, do you think that that this kind of accessibility to education through the internet will reduce the demand for teachers? Do you think that, you know, there'll be less incentive for people to go into education? Because, like, for instance, like in my high school, actually, my physics professor would just, you know, put you on the projector and then, you know, go play video games on your laptop. And, you know, after a while, you know, we start to wonder why we have a physics professor if we have Walter Lewin available to us.
Can you summarize what you said in a few sentences?
Yes.
I have a hearing disability. It's not your problem.
That's okay, I'm also a quick.
If you think that there will be less need for teachers and less people going into education, because she said, for example, that she had a very bad high school physics teacher, but luckily she could watch your video. And what was your notion? So what was your point? That you could watch his videos and forget about your physics teacher, essentially.
Our physics teacher no longer
she could forget.
What's wrong with that? Nothing.
No, so she was wondering whether you think that there will be less teachers in the world. You think?
Yeah, there will be fewer. And those that will do physics would have to do much less work, so they may actually have double appointments or so. Yeah, sure. I would like to think that apart from the fact that you may put a lot of emphasis on doing yourself things, putting at a solder iron and having a capacitor and having a battery and having an explosion right in front of you, apart from that, I think you can learn 801 physics entirely from my lectures, in every detail, in every aspect, because there are the problems, there are the solutions, there are the exams. Yes, I think so. And the demonstrations.
Well, there are people who do.
And same is true for my 802 and for my 803. Now, of course, there comes a time, like if you're a physicist, that you have to take 813 and 814, then you have to do the lab. But that's a different thing. That you cannot replace that in any other way. And it is reasonable to demand from physicists that they can work with an oscilloscope and that they can put circuits together, they can interpret that, and they learn about accuracies and systematic errors and all that. They reproduce experiments, measure the speed of light, and all that. It's very important. That you have to do at an institute where you have all the equipment, which is not cheap. You cannot replace that electronically. So many subjects, yeah, can be done. Now already today, 100% e-learning. And that will only expand. Don't you think so? Yeah.
So, Professor, if for example, we have OCW, right? So that means that people who don't go to MIT have access to MIT courses and problems. So then what is the benefit, do you think, of students actually coming to MIT if they can just access the material without physically being there?
Oh, you know the answer to that yourself. Oh, don't play games with me. You apply for a job and you say to your employer, I have seen all of Walter Lewis's lectures and I know exactly how to do it. And the guy will say, isn't that nice? Now you come to the same guy and you say, look, I'm a bachelor's degree with MIT. And then he doesn't say, oh, that's nice. You're hired. You know what MIT-X is?
Yeah.
Yeah? Have you heard of MIT-X?
Yeah.
Well, so MIT is going to give certificates away, right? Beginning already. It's a first start. It's not a degree. But I can imagine that a lot of people will feel very good when they apply for a job, that not only on their CV they can mention that they have this certificate from MIT, that they have successfully taken all the problem sets and taken all the exams and passed them, or for instance 6002 X. And they can show that they have a certificate. They have something to show on paper. So and of course Stanford is going to do that too. That you're going to see. That's just started a few years ago. That will become explosive all over the world. Universities will start giving certificates, which is still different from a bachelor's degree at MIT. But it's wonderful that it can be done. You have to pay a little bit for the certificate, which is still an issue at MIT, because how could you charge someone in India $30 for a certificate? It's ridiculous. They don't have it. They don't simply have the money. $30 is a year income. Why would you Why would you charge my daughter in California who's married to a millionaire? Why would you charge her $30? That's equally ridiculous, right? So you must have a sliding scale now. You must charge my daughter $10,000 and you should give it away to the person in India. That MIT has not worked out yet. That's very difficult. And how that will evolve, I do not know. They're wrestling with it. They haven't decided on this yet. Very, very difficult. Because now it comes down to show me the tax return of your parents from last year, and then we will tell you how much we will charge you for the certificate. That's really where it comes down to. That's a very difficult issue. There's another issue which I do not know how MIT is going to cope with that, although I've asked that question. How do you know that Bill Williams, who gets the certificate, that he actually did the work? Why wasn't it his brother, who was already a PhD in physics, who said, oh Bill, don't worry, I'll take the course for you, and we will just register your name. Now how they deal with that, I don't know. We don't have voice recognition yet, we don't have eye contact recognition yet. It's inconceivable that MIT would introduce a system whereby they would want an identification and then enforce the identification, that you every time know that it is the same person who is doing it. I really don't know how they're going to cope with this. I've talked to the person who is in charge of MIT-X because they want me to do MIT 801X and 802X, they have asked me. He says, well, there are ways that you can tell whether it's always the same person by the way that you type. Well, that may be, but you don't know whether it's William or whether it's John. So the computer can recognize that it is the same person. You can't make it an honor system for 1 million people, an honor system. That would be absurd. Take their word that they really took it. That's absurd. I think all those difficulties will be overcome. I think they are now major, but they will be minor 5 or 10 years from now. So I think it's great. There was a time that MIT and places like Harvard were like the Forbidden City. The doors were closed and you had no idea what was going on inside. And then came OCW, which was the first one in the whole world, who said, you want to know what it looks like inside here? No problem. Open the doors. 2,000 courses. Now, they're not all videotaped, but the problem sets are there, the lecture notes are there, so you get a pretty good idea what's going on at MIT. That's how it started, 2001. Now 10 years later, explosive, all universities do it. And YouTube YouTube and iTunes U and Earth Academic have all taken over all my lectures. You can see them anywhere. There was a time that if you want to see one of my lectures, you had to put in some effort. We've now reached the point, if you make no effort, you cannot avoid me anymore. If you go to Wikipedia, as an example, and you ask angular momentum, you will see a 5-minute clip of my lectures. There was recently an advertisement for underwear. How the hell they coupled that with the videotape of my lectures? But they did!
What principle would